Hi geometry students, it is Tuesday, February the 9th, and here we are just cranking through February. And today's lesson is on trapezoids, and oh my goodness, I spelled it wrong, so I'm going to fix that first. Sorry, there we go, trapezoids. So the first lesson is learn how to spell it. Mrs. Jernigan obviously did not know how to spell it. So make sure that you know. It looks like it's trapezoids, but it's trapezoids. So look at page 332, and we are going to begin with some definitions. So let's begin at the top. Now, a trapezoid is a quadrilateral, so we know that that's got 4 sides, with exactly one pair of parallel sides. The parallel sides are the bases. So in this diagram here, you can see the base lines are in red. Those are the ones that are parallel. The ones in blue are the non-parallel lines, and they are the legs. Those two lines, if they continued onward, would eventually meet. Our parallel lines will never meet. A trapezoid has 2 pairs of base angles. So in trapezoid A, B, C, D, this one up here, angles C and D are 1 pair of base angles, and angle A and B are the other pair of base angles. So make note of that. If you have an index card that you're writing down the definition of a trapezoid, bases and legs, make sure then that you note what the base angles are. If the legs of a trapezoid are congruent, then the trapezoid is an isosceles trapezoid. So it is entirely possible that they measure the same. So here's a leg. And here's a leg. We know, I'm sorry, my little curvy picture, my camera just won't take great pictures. These two are parallel, but here's a leg and here's a leg, and we learn that those are congruent. So they measure the same, but they're traveling in such a way that they are going to intersect at some point. They're not parallel. Okay, so now let's take a look at some theorems. As a result of the information that we have some theorems. So we learned about, we've got that word isosceles popping in here again with trapezoids. If a trapezoid is isosceles, then each pair of base angles are congruent. That kind of makes sense. We've got these 2 lines are equal. They measure the same. These 2 lines are parallel. So we've got 2 different things going on here. We've got those parallel lines shooting off into infinity, never meeting, but we have these 2 legs, A and D and B and C, that just happen to measure the same thing. If that's the case in the isosceles trapezoid, we will have some congruent angles. A and B will be congruent, D and C will be congruent. So again, very important information for our potential proofs and things that we might have to solve with trapezoids. Theorem 6.13, if a trapezoid has a pair of congruent base angles, then it is isosceles. So, if D and C, if we find out in given information that D and C are equal right here, then we know that these 2 are going to be equal and the trapezoid will be isosceles. So this is all about the isosceles piece. I know that's a mouthful to say that, but it's showing the base angles, the congruency of those. If we end up having congruent angles, then we know that we've got these 2 legs that are equal in measure, and it is an isosceles trapezoid. Okay, let's take a look at some, it says A, B, C, D, and I'm sorry, I cut some pieces off. So I think A is right down here, B is right here. A, B, C, D is an isosceles trapezoid. Find the missing angle measurements. So since we know that it's isosceles, trapezoid, we know that D and C are equal, and we know that A and B are equal, even though Mrs. Jernigan cut them off. So we know that D and C are going to both be 100. That brings us up to 200. Now, how much do we have to get to in a parallelogram? Well, hopefully everybody shouted out really loud, 360 degrees. So if we're at 200, that means we have 160 left, which means that each A and B need to have 80 degrees. So, and these are in your book too, so you can look at them in your book if it's a little bit easier to deal with them. All right, number 2. We know that C is 70, but they've already told us these are all isosceles trapezoids. That means D is also going to be 70. That's going to leave 220 degrees. We divide that into half and we get 110. So A and B, those are a little bit bigger, so that makes sense. 110, 110. Okay, then in number 3, we have 75 degrees. Now, I know this one looks a little skewed. That's because of my camera. And A and B are equal though. So A is going to be equal to B, making it 75 degrees. That is going to give us 150 degrees, which leaves 210 degrees still for the trapezoid. That means that each of D and C are going to equal 105. So hopefully you were able to work those out in your mind as we were going. Okay, next we want to take a look at right underneath of the checkpoints that we just did. We have what's called a mid-segment of a trapezoid. And in this, the mid-segment of a trapezoid is the segment that connects the midpoints of the legs. So remember, here's our legs. Boop, boop. The mid-segment is connecting the two midpoints of the legs. That's going to mean the mid-segment of a trapezoid is parallel to the bases, but that's going to mean that it cuts these in half. And this would be congruent to this, and this would be congruent to that. Now, if we wanted to find out those measurements, we have a little formula that we can use. And so you see down here that MN equals 1/2 of AD, here's AD, plus BC. So if we knew that this one equaled 8 and this one equaled 10, we could add those together. And AD, what did I say, equaled 8, and this one equaled 10. That's 18. 1/2 of 18 would be 9. And that means that MN would equal 9. So they've even thrown in a new little tool in our toolbox to help us figure out just a little bit more about trapezoids. So let's take a look at the example here. And that's right under the mid-segment information that they gave us. It says find the length of the mid-segment, that's DG. So that's this piece right here. Find the length of the mid-segment for CEFH. Lots more letters in trapezoids. And so we're going to use that formula. So DG, we're going to put that right here, equals 1/2. And then we have EF is 8. So we put 8 in right here. CH is 20. And so we get a total of 28. And 1/2 of that is 14. And so we find out that DG is 14. So we're now able to add another formula. We have not added a whole lot of formulas to our index cards this year. So if you have a special section for formulas, you can put it in there. Otherwise, you can just keep it with your trapezoid section. But this is one of the few formulas. We are going to get a few more of those as we move on to circles and radius and those kinds of things. But this is another formula that you can put in your toolbox. All right, so let's practice with those. And we are going to look for the mid-segment of, in all of these, it's going to be MN. So again, the answers are up here because I only have the teacher book. So we would look at the first one and we would add 14 plus 8 and we would get 32, and we would divide that into half, and we would actually, they've got 11 is the answer to that. Whoops, I'm adding wrong. I should have said 22 and not 32. That would make it 11. I think my brain is ready for winter break. I wonder who else is ready for winter break. So 14 plus 8 is 22, not 32. And half of that then is 11. So that's correct. Then in this one, we would add the 10 plus the 6. We get 16. Half of that is going to be 8. And down here, we're going to add 18 plus 24, and we are going to get 42, and half of that is 21. So some of the homework that you will be doing has to do with finding the mid-segments and finding angles for our trapezoids. So do the homework. If you have questions for me, please bring those in for class on Wednesday. And on Wednesday, we will be doing a little bit more hands-on stuff with quadrilaterals. So we'll be looking at 6.6, and I will plan to see you then. Have a good day.